Hi there guys, it's me again. There wasn't a tutorial for Genome2D in quite a while, and unfortunately this is not going to be a tutorial on Genome2D. I just want to show you something I've been working on, and that's the new upcoming Genome2D haXe version. I work on the ActionScript version as well, because that's the main version at the moment, and it will continue to be for a long time probably. But I'm playing with the haXe version as well, just for some awesome features and performance as well. So let me show you how to work with the haXe version. I'm using the IntelliJ ID. It's because I can't use Flash Builder for haXe obviously, and I was using Flash Develop before for haXe. It's great, but kind of like the new IntelliJ, because I can do all my Java ActionScript, the JavaScript and haXe work inside one ID, so it's kind of awesome. And I kind of wanted to get rid of Adobe because Flash Builder crashes quite a lot. Anyway, for those familiar with haXe, they already know that we need to start the application, the main class, with some kind of static main function. So we initialize the constructor of the main class there. And for those unfamiliar with haXe, I don't think you'll have any problems, because it's very similar to ActionScript. So it only builds on top of ActionScript features, so you can only gain, you can't lose anything. So let's start. We are building a Genome2D example, so I already prepared a skeleton. So Genome2D get instance, it's the same. The haXe version has the same API as the ActionScript version. There are small differences because they are needed from the haXe standpoint, or because I thought that they are better than the current ActionScript version, and all those features that I think are better in the haXe version will be ported back to the ActionScript version as well. So the API is consistent across the languages. And there are also some new features in the haXe version that are not available in the ActionScript version, that are going to be implemented there as well. So genome on initialized, callback on Genome2D initialized. Now we need our config. It's pretty common stuff. All people that worked with Genome2D know this already. So we need a rectangle specifying where the stage 3D will be initialized, and now we will initialize the genome. We need the stage and the config. So let's try it out. Trace on initialized. Or just run it out if it works. You don't need to trace it. There are a few problems with tracing in IntelliJ and haXe projects, so I kind of want to avoid that. Okay, it runs. Now we need some graphics that's going to be shown. There are new features in the haXe version, and there are asset management. It's needed for other reasons as well, but I kind of like it, so I'll port it to the ActionScript version as well, so you can use Genome2D for your asset management as well. So we are going to create an asset image with the ID of crate and the file of crate in We are going to hook a listener on us, load it, and load it. You can specify the URL to override the URL specified here if you wanted to, but it's kind of like the loader, Flash native loader. So once again, run it. If it works, everything works. And now for the common G2D stuff, we are going to use the G texture factory create from bitmap data. ID is create as usual, and we are going to use the asset that's we need to cast it to the asset image, and we are going to use the bitmap data of it. Once again, run it. As you can see, haXe compiler is pretty fast, way faster than the ActionScript compiler. So, and now we will show something. Genome, root, add child, sprite node. And it's there. Everything works. As you can see, there are very few minor differences between the haXe and ActionScript. And that is, for example, the casting here. We need to cast this, because this always returns a G component instance. So whereas in ActionScript you would type it like this to cast it as sprite, in haXe you need to cast it using the cast. And that's pretty much it. So, and now for the new features. You already saw the image asset. There is the XML asset and the manager. I will show you in a while. For the asset management, the additional feature that's coming to the haXe version of Genome2D is the bitmap context, which is the Flash native renderer. It's using the blade and draw functions. So you can pretty much use this anywhere where the direct V mode or stage 3D isn't available for some reason. So let me show you. We'll just use the other config, which is the bitmap context config. And this is now using, it's the same thing obviously, but it's now using the Genome2D software renderer instead of the stage 3D renderer. This is not stage 3D using software rendering. This is pure software rendering outside of stage 3D, so it doesn't even initialize stage 3D. Another great thing with the Genome2D haXe is that we can target other platforms. There are currently two other targets supported in the alpha version of the haXe, and that is the HTML canvas renderer and HTML WebGL renderer, which is in pre-alpha, and I will not show it at the moment, although it can render pretty much everything the others can, but it's not polished enough. So let me show you the canvas renderer. So we will use config ghtml canvas context config, and it's the same stuff. It's the there will be a few changes here because a rectangle is the Flash geom, you can't use it in JavaScript target, obviously, or you can't use sprite as well. So we will change these things. We will remove these dependencies. The stage here, it's there is a new feature of the init function in the haXe version. Null will automatically look for your stage, so will detect if it's Flash, it will automatically look for the stage of the movie clip, and if it's JavaScript, it will look for canvas node. So now we need the G rectangle, which is a new Genome2D class, which it's typed def to the Flash native rectangle if we are using Flash target, but if we are using the JavaScript target, it's a custom class that emulates all the Flash stuff. So it's the same thing. And now we need to specify in the compiler that we want to target JavaScript. I have this already. You will target JavaScript, and I have a little build JS HXML. It tells us that the main class is the example. We need to use the msignal library, haXe library, because Genome2D uses that library. It's the AS3 signals library used by the Genome2D ActionScript, ported to haXe. And I'm using the actuate library in the other examples. I'm not using in this one, but let me leave it there, and we will compile it to the example.js file. So let me run it. It will tell us that we can't run JavaScript, obviously. So let me show you. I will take this and move it to my web server so I can run the example. And it's here. This is pure HTML5 canvas with the same code base. There is no compile time directives telling us that this is JavaScript or anything. It's pretty much the same code base. So these three kind of chaotic. So a new feature in the haXe version is that you can ask the genome for the best config for you. So let's say we want the context config. We don't know at the moment which config we are going to get, because let's say we don't know if we want to compile to JavaScript or Flash at the moment. We just want to change the settings without changing the code, and it should work. Obviously, we don't want to mark this if we are targeting JavaScript, and remove it if we are targeting Flash and stuff like that. So let Genome2D handle this for us. It's the context config get available method. So first parameter is if we want a GPU. Well, we want GPU, obviously. So what this does is that for Flash, if it's true, it will return stage 3D config initialized, and if it's false, it will return the bitmap context config. And for JavaScript, if it's true, it should return the WebGL. It's removed at the moment; it's not implemented. And if it's false, it should return the canvas config. An additional feature that's coming, and it's in the work in progress state, is that it will degrade automatically. So you can specify this to true, and it will try to initialize the GPU version on each platform, and then move to the software version once the GPU initialization fail. It already works in some of my WebGL haXe pre-alpha demos I posted on the internet. So, and obviously the other parameter is the rectangle where the canvas or the stage 3D or the bitmap will be initialized. So let's move back to Flash so we can easily preview this stuff. And as you can see, it works. It will automatically detect that this is a GPU enabled Flash player, and it has a stage 3D, so you don't see it obviously, but that's how it works. So let's move to the other examples I prepared here. I'm not going to write them. Let's say we want to the basic example. Again, it's the Genome2D at its finest. It's using the movie clip and component for the movement. It's pretty much the same thing as the ActionScript version, all ported to haXe. The kind of choppiness that you see, that's because I'm recording this video. It runs flawlessly, but on the video you will see that it's not flawless. So again, it's pretty much movie clip as we know it, and frames, texture atlas ID, go to frame, and move is our custom component that I created here that will move the stuff around and bounce off the screen. So you can create the components the same way as you could create them in ActionScript, and you should be pretty familiar with this. So if you remove the component, obviously it will only create the knights and they will not move. They will just run. Additional new stuff here in this example is the asset manager. For the asset management I mentioned. So we will initialize the asset manager and hook up the onloaded callback, and then push all these assets there. It's an image asset, XML asset, and then load, which will load queue. So we will load this, then this, then this, and once all of this is loaded, it will fire the callback, and now we can create all of our textures and stuff from directly we can get it from the asset manager as get asset image by ID and asset XML and stuff like that. It's pretty simple asset manager, but it's very handy, especially in this haXe version of Genome2D, because it's kind of a mess to handle asset management multi-platform in a multi-platform way. So you want Genome2D to do this for you, because in Flash it's cool. You can do var loader and load this, load that, or your URL loader for the XML, or you can even embed this to this Swift. But what if I want to touch JavaScript? There is no loader, there is no URL loader, there is no embedding, stuff like that. So let Genome2D handle this, and it knows that if it's a JavaScript, it should use a different approach to loading images and let you know when once it loaded. So let's move to the next example. It's a camera example. This is quite new. I finished the camera support for all the render targets just 2 days ago. So let me show you. So pretty common stuff. We have this grid of crates in the scene, and we have 2 cameras that are looking into the scene. One camera is moving and rotating and zooming, but it's the same scene, and we have these mouse events interacting with this scene, and popping up the crates. As you can see, when I interact here, the crates are popping up, and if since this is the same crates on the right as are on the left, it's the same scene, but just viewed by two different cameras, you will obviously see that mouse interacting in the right camera, which will change the left camera as well, since it's the same scene. And both of the cameras have their own mouse interaction, so even if they were overlapping, the camera on the top would capture the mouse events, and it will not progress further down the other cameras. So let's say we want to change the cameras a little. We can do that. It's the same thing as the ActionScript version, just let me show you a little. We will change the first camera to the whole screen, and let's change this to the top right. Top right of the screen, so it will be on top of the first camera, so this will show you that you can also overlay cameras as well easily. You can specify a background for the camera as well if you wanted to, so you can have even unlimited amount of cameras. If you don't specify any camera, it's the same the ActionScript, latest ActionScript, the Genome2D version. It will create a default camera for you to the whole screen. Once you specify a single camera and add it to the genome root, it will disable the default camera, so you need to do all your management yourself if you are using custom cameras. And as you can see, I'm using the Actuate Twin library to move the camera, the first camera, the rotation and stuff like that, the effects. That's the haXe. It's pretty simple, so migrating from TwinLight to the Actuate was very easy. So all this works in JavaScript as well. Let me show you. We will just specify that we want the JavaScript again. Very simple. We can have these HXML files for Flash and for JavaScript as well, but you don't need to use this for Flash if you don't want to. Anyway, let's compile the JavaScript version, and let's copy it to the web server and run it. Yeah. I will just change the JS file for this HTML. Let me refresh it, and as you can see, it runs flawlessly, and this is the HTML5 JavaScript target. So let me show you something. Let's combine the camera example with the first example and move the little fellas around just for pure visuals. As you can see, it works. They overlap because we didn't change the normalized view to the half the screen of the left camera. So it's basically the first example seen looked by two different cameras. And once again we can have it in all three targets. So I prepared this, so we have the index flash HTML, which is, if we change the source, it doesn't use direct vmode. This is the flash native renderer, not the stage 3D. And we have the index direct HTML, which is direct vmode with this single code base. Now let me show you something else, and that is the gem, which is our game based on Genome2D. I ported it to haXe, and I wanted to show you that it was very easy to port, and it uses single code base. There are no compile time directives, so we can run this in Flash stage 3D. This is the game. And once we have this ported to haXe and Genome2D, we can easily switch this to the JavaScript, just like that. Nothing else needed. There is no JavaScript specified context. Okay, I have this here. It shouldn't be here. Let's try this again. Okay. What's going on? Oh, I know. We can't do it like that. We need this. Okay. So again, it's compiled to JavaScript. Let me show you. I'll copy it to the web server. It's gem index JS. Let it load, and this is it. HTML5 canvas compiled using Genome2D. And this will run on iOS, Android, pretty much any browser as well. So even the old browsers, some people tested it on the 3GS iPhones. So it's kind of cool. And again, I have all these compiled to all other targets. So this is the window. This is the bitmap target. Flash native, not using the stage 3D, so you can port this or hang this, or how to say it, to all the Flash portals that don't support the direct vmode. And then we have the direct. As you can see, there is no difference. It renders exactly the same. One wouldn't say that it's three different targets. So I hope you liked my presentation. It shows that we don't need to build Genome2D in 5 different languages like some other people do. It's very easy to port Genome2D to TypeScript or C# or something else, but why would we do that? Even if haXe wasn't there in the future, we still have the Genome2D JavaScript files from this, so you can even use this compile JavaScript Genome2D and create your own JavaScript projects on top of it. There is no limitation. And another thing is that it also supports, and the haXe Genome2D is created in a way that you can compile it to the Swig files. So you can use the same Genome2D in the ActionScript project as well. It's kind of a lot of work because how haXe handles Swig files, and because there are some specific, for example, getters, setters, and stuff that need to be sorted out. But it works. So let me show you. Let's run the Flash Builder, which I'm not using anymore, but just for the sake of it. And we have the Genome2D. This is test Swig. It's the haXe compiled Genome2D. I can show you that it's it because, for example, G transform, let's say, as you can see here, there are a lot of these G2D underscore stuff. This is because haXe, once compiling to Swig, it will make any variable as a public. So all these are actually private variables, but because how haXe compiles them, I needed to this prefix to show you that you shouldn't touch these unless you know what they're doing. So you can run this. Is the ActionScript project using the haXe compiled Genome2D. And as you can see, it's the same example. Our armored fellas running all over the screen. So you will get all the cute new features like the G bitmap context, obviously. All this if you still want to use ActionScript. So you don't need to worry that I'm just working on the haXe and you need to move your project to haXe. No, you don't need to move them there at all. You can still use the same Swig and with all these new features, and it will even boost the performance because there are some neat optimizations inside the new haXe version. And let me finish with a little bit of physics example to show you that even physics, it's already in the alpha version of the haXe, and it works. It's the okay, I forgot to include the NAPI. It's using the NAPI extension for Genome2D and obviously the NAP physics library by Luca. It's awesome library. It compiles quite a little bit longer because it also compiles the NAP library. Oh, jumping around because I have some weird materials set there. Anyway, and you can also, since NAP is haXe as well and it's cross-platform, you can also compile this to the JavaScript, which is awesome. So let me show you. I will run it here. Let's move it to the web server. And it's here, HTML5 physics on top of Genome2D. Yo! And it runs quite smoothly, unless you are recording a video like I am at the moment. So, guys, again, I hope you like it. What's the future for Genome2D? I'm still working on it. I'm still working on the nightlies for the ActionScript version. So that's the main concern for me at the moment, and I am resolving all the issues you guys are testing and sending me. So if you need anything, just write me an email or go to our forum at forum.genome2d.com, or you can even talk to me on Skype. So I'm always helpful for people using Genome2D. And next week I will be presenting a short presentation on how to write your own filters and post processes for the Genome2D on the Stage 3D online conference. So if you are interested in that, don't forget to attend. Thanks, that's all for now, and any feedback is welcome. I'm always listening. Thanks.